Alright, so when we're going through our need to knows, elementary charge. So elementary charge, and it's on your equation sheet, is the charge of an electron, 1.6 times 10 to the negative 19 coulombs. And all other charges that exist in the world, all other charges, must be a multiple of it. So you can have 2 of them, you can have 5 of them, you can have 27 million of them, but you cannot have half of that charge. Or 7.5, or 21 million point 5 of that charge. Total charge is conserved. Electrons do not just disappear or appear. Same with protons, so the total charge must stay the same. Similarities and differences, we'll get to number 1. When 2 conductors touch, the total charge spreads out, so they share that total charge. Opposites attract, likes repel. Positive and neutral will also attract, or negative and neutral will also attract. You get questions a lot that'll ask for like a new force in terms of the old force. Well, you can just find the 2 and then just do new over old, and that will give you the factor difference between them. For electricity, in one closed loop, the sum of the voltages should be 0. So that's like a positive voltage from the battery minus all the drops. So you can think about it as all the drops add up to the positive positive voltage of the battery. Or you could say the battery minus all the drops give you 0, which is what this rule means. When you have like an intersection or a junction, all the current in must equal the sum of all of the current out. So if you have 5 amps coming here and you know it splits up, doesn't matter what they split up into, but they better add up to 5. Potential difference is just asking for voltage. Remember, the definition of voltage is the difference in electrical potential energy between 2 points. Current is the rate that electrons flow in a circuit. So it's by definition it's like delta Q over delta T. So it's how much charge per second. Well, it's actually the electrons that are flowing, so it's the rate that charge is moving in a circuit. Power is the rate that electrical energy is transferred. So the definition is P equals IV. P is measured in watts, but the meaning is like how much energy it's using like per second, electrical energy. Open circuit, short circuit. Open circuit is no current flow because it's open. Short circuit is when you give an easier path for current to take. So either way, like the bulb or whatever it is isn't getting current. So open current is very straightforward. Short circuit is like if I have something like this and I put a wire right here, well now instead of current going through the bulb, now it just goes along like this. That's short circuit. I'm providing a shortcut so it'll go there instead. Alright, similarities and differences between the electrical force and the gravitational force. So the similarity is that they both depend on the 1/r squared. So if you get bigger, right, yes, they are both getting smaller, specifically by like 1/r squared factor. Differences is that Fg is smaller on average than Fe, because G, the constant, is much smaller than the constant K. It's like 10 to the negative 11 and times 10 to the 9. So much bigger, much smaller. The other difference is that gravity is only attract, whereas the electrostatic force could be attract or repel, depending on if they're opposites or alike charges. Scientist is doing an experiment and finds that the charge is this, plus or minus this much, which means like within a margin of error, right, give or take. So what I'm going to do is I'm going to give and take this much, see what my range is. So that would be like 5.35 e negative 19 coulombs, somewhere between that and 5.25 e negative 19 coulombs. Now, this range, right, I don't know off the top of my head if this is like a very reasonable range. What I would need to do is I would need to put that in elementary charge, because elementary charge is the one that I would know if it's reasonable or not. So I'm going to divide by the elementary charge. So go ahead and put it on here. I get that that would be 3.34 elementary charge to about, same thing, but with 0.25, 3.28. So going from between 3.34 protons and 3.28 protons, no, that is not reasonable, no, because you can't have part of a proton. I just said proton in this case because we're talking about positives, or you could say part of an electron, it's fine. Same thing, so give or take 0.1, so this would be minus 6.25 and minus 6.45. Right, now I'm doing the exact same thing. I'm going to divide by my charge, see what this is in terms of elementary charge. So this is 3.9, and this one would become 4.03. So here, yes, that is reasonable, but see how that's like, oh, that could just be like 4 electrons. So yes, because can be negative 4 electrons, which is totally fine. Right? Of course, if I get this, that's not exactly negative 4, but right, with an experiment, there's some error. So that means, yeah, I was just really close, but within some error, that means I just had 4. Here, right, that's not within my error, so I did something wrong. All right, so we've got A and B. We've got positive 4 microcoulombs. I've got positive 10 microcoulombs. They are 2 meters apart. Now I know they have a force F, B is removed, and C is placed with negative 3, and now they are 6 meters apart, obviously not to scale. Right, microcoulombs, so micro is one of those, like, similar to like centa and milli. It means times 10 to the negative 6, but because I'm going to be finding like factor difference, I know at the end I'm going to do new over old, so these micros will all go away, so I'm just going to kind of ignore them right now. So I've got K 4 micro times 10 micro over 2 squared. This guy I've got K 4 3. I'm not putting in the negative 3 because it's going to get absolute value in my equation, so it doesn't really matter. That just tells me positive or attract or repel, which I don't care about right now. So, and now I've got, this is 12 over 36. This one is 40 over 4, which is just 10. And there's K still. Now I'm going to do new over old, 12 over 36 over the 10. K's cancel out, just like the micros would have if I had not ignored them from the beginning. And then now you just do in your calculator, math, enter, enter, and you get this is 1/30. So if my old force is F, the factor difference is 1/30, so my new force is just 1/30 F. Here we've got negative 9q, positive 1q, separated by a distance d. And they have a force F, so this is k 9q 1q over d squared. Now they touch, so right now it's negative 9 and 1. That is not going to be the case after they touch, because what's going to happen is their total charge is going to split evenly. So if I have negative 9 and 1, that gives me a total charge of negative 8. So then if it splits evenly, negative 4q, negative 4q. Now I find this force, k 4q over d squared. You hopefully by now can see when you do new over old, the k's and the q's and the d squareds will go away. So you will just have the 16 over 9. So then 16/9 the old force. Here we've got R is plus 3 microcoulombs, 1 meter from E, which is plus 7 microcoulombs. Magnitude of their force is F, so I've got K 3 7 over 1 squared. Now R is removed and I've got negative 4, placed 2 meters now. Still have E, which is the 7, so K 4 7 over 2 squared. So that's 14 over 2, and this one is 21. So now I'm going to do new over old, 14 halves over 21, 14 halves over 21, and you math enter, enter, and you get 1/3 the old force. Notice that I kind of knew that these K's were going to cross off, so I just kind of ignored them. Same as number 5, very similar. So this is going to be 24. And when they touch, it'll be -5 and -5 because the total of 10 split evenly. So that will become 25 q over d squared. So new over old, you get 25 over 24 fourths. The other fourth. 25 over 24th. Okay, whatever. All right, number 8. So I want to know which of the following could represent the circuit that matches the table. So here we're just looking like, would they have the same voltage? Would it be the total? Would they have the same current? Would it be the total, etc. So first I looked at voltages. I know that nobody has the total voltage. So I looked at my, well, automatically I can answer it actually. Here, see how R1 would get the total voltage? Well, that's now what's happening, so this can't be it. And this one, R3 would get the total voltage, so again, now it's happening, so it can't be this, so that's what's left. But let's talk about why this makes sense. So nobody gets the total voltage. You notice that R2 and R3 are the same voltage, which makes sense. They have to be in parallel, so that had to be true. It also makes sense that this guy has the total current, right? Battery current in R1 are the same, so we knew that R1 had to get the total current. And then you notice that these two split. They don't have to split evenly, but they do have to add up to the total current, which these two do check out. And this voltage and this voltage do have to add up to the total, which was 4 in this case. So then if you check, yep, these add up, and R1 and R3, their voltages have to add up as well. So this one, because this one adds up to the total. So we're good there. If I take away one of these 2 ohm resistors, what happens to the potential difference? So just talking about like timing strategy here, in class I saw a lot of people that did the reasoning. Okay, I'm gonna figure out increase, decrease, and they spent like a minute or 2 figuring out whether it increased or decreased, and then they had to do the math to figure out how much. Because you're gonna have to do the math anyway, your math is gonna tell you if it increases or decreases, so just be like strategic with your time. If you're gonna have to do the math anyway, then don't worry about the reasoning through why it increases or decreases, because you're gonna get the numbers anyway. So if I wanna know what happens to it, first I need to know the voltages before, so I'm gonna get my R total, so 1 over 2, 1 over 2, because these two are in parallel, don't forget 1 over that. So that becomes 0.5. And then add that, so, did I do that right? I think that becomes 1. Yeah, it becomes 1. So this one is just 1, and then with the 4, our total is 5. I total is just total voltage over total resistance, so 10 volts over 5 becomes 2 amps. Current splits here, but then this guy does get the total current. And then multiply, because I is V over R, so you just multiply I times R to get the voltage. That gives me 8 volts. Now, and you can find these, but if we're trying to be like careful with our time, right, I actually don't need them. I just care about the potential difference across the 4 ohms. So first it's 8. Now I'm going to take out one of the 2 ohms, so that it's just 1, 2, and 1, 4 ohm. R total now is 6. I total would be 10 over 6, which is 1.67, so 1.67 amps, and then multiply to get your voltage. So this one now has 6.67 volts. So first it was 8, now it's 6.67 volts, so I just subtract. Obviously this went down, right, from 8 to this, it decreased, so I can cross off these ones, and it decreases not by 0.33, but by 1.33. So your answer is E. 10, current through the battery is just asking for I total. So first I'm going to find R total. I did these 2 in parallel. Some people are tempted to do 5 and 6. So they go, oh, this isn't serious. No, they're not. 5 has the current that's coming out of the battery. It has the total current. As soon as it gets to this little intersection, this junction, it's going to split in 2. So this guy does not have the same current as 5. It only has part of the total. These 2 split current between them, right? They have the same voltage. They're in parallel. So I'm just going to add those together with my 1 over. That becomes, check my 2. And then you have the 5 and the 2, so our total becomes 7. Now I want the total current, so I total is V total over R total. Total voltage is 14, total resistance is 7, so total current is 2 amps. The current through the battery is 2 amps right here. So that would be like this. These two do not get 2 amps. I'm also not going to say, oh, it splits 1 and 1, because they actually have different resistances, so more current would go here and a little less here. But what I can find is this guy's voltage. Resistance of 5 and a current of 2 is a voltage of 10 volts. I know that my voltages in this single loop need to add up to 14. So if this one is 10, this one is 4 volts. And for the exact same reasoning, or you could say because they're equal, because they're in parallel, this would also be 4 volts. And then to get the current, I just do I is V over R. This guy's voltage is 4, this guy's resistance is 6, so then your answer is 0.67 amps, or 2/3. Here, I told you in class that I needed to put the current, it was 0.5 amps. So now I'm going to say 0.5 amps for each of these, because this is a series circuit, so current is the same. Here, current times resistance gives me a voltage of 25 volts. This is my total voltage, so I know that my total, my 2 voltages need to add up to it. So I'm just going to subtract. If my total is 120 and this has a voltage drop of 25 already, then this one would have to be 95. Now I just want the potential difference, which is the voltage, so I just want 95 volts. Done. Here, so the sum of the resistances here and here become 10, so I'm just going to redraw this as a 10 ohm, and then this 5 is still here. And because you have your 4 amps, we have enough information right here to find the voltage. This has 20 volts, which means the battery must have 20 volts because it's in parallel with the battery, which these two do not both get 20 volts, but combined they get 20 volts, so you can say the 10 gets the 20 volts. I want to find the current through the left branch, so I just immediately went here and said, okay, 20 volts. Ooh, wait, no, I equals V over R. 20 volts over 10 ohms gives me a current of 2. So then your answer is 2 amps right here. Other people found R total by doing the 1 over 10 and 1 over 5 and 1 over that. That's totally fine. You get R total. I didn't do it that way, so you get R total is 3.33. Then you would do total current is total voltage over total resistance, and you get a total current of 6. And then if you have 6 amps coming here and you know 4 went this way, then you must have 2. That's the other way to get the missing 2. Either way works. Here we are ranking the potential difference across each bulb from greatest to least. So it says they're all identical bulbs, which means same resistance. Here, I'm going to start with my currents because I know that current is total current here, and then it splits evenly, and then it comes back together. So these two are both getting the total current, so I'm going to make a note. They both get I total. These two do not get I total. So I know that these two would be equal because they have the same current with the same resistance. So I'm going to say the voltage across A is equal to the voltage across D. I also know these two are equal just because they're in parallel. So I'm going to say the voltage across B is equal to the voltage across C. And then for the reasons I just stated about current being more here, because it has more current than these two, this would have a greater voltage. So these two are greater than these two. So now I need to explain why are these two equal. These two are equal because B and C are in parallel. These two are equal because they have the same current with the same resistance. And these two are greater, so A and B have the greater current because they get the total current. And more current with the same resistance is more voltage. Now bulb B is unscrewed, so I'm going to redraw it as A, C, and D. Same battery. I want to rank the potential differences now. Now this is very different than saying what happened to the potential difference. Did it increase, decrease, stay the same? That's not what I'm asking. I am nothing to do with this. I'm just saying, okay, take B out. How do these rank now? Now they're all 3 in series. They're all the exact same resistance, so they have to have the same. So then the voltage across A is equal to the voltage across C is equal to the voltage across D, because they all have the same current, because they're all in series, with the same resistance. If they're not the same resistance, they will not have the same voltage, only because they have the same R here. What happened to the potential difference across A when bulb B was unscrewed? This is saying, okay, from this one to this one, what happened to the potential difference? Did it increase, decrease, stay the same? So think about it, your potential difference is just I times R. The potential difference across A, right, is the current through A times the resistance of A. The resistance of A stayed the exact same. The current through A did not necessarily stay the exact same. So that's really what I'm asking here. What happened to the current through A? Well, the current through A is just the total current. Total current is total voltage over total resistance. When we're talking about the total, I still have the exact same battery, so this stayed the same. My R total did not stay the same. Okay, so my R total, if you don't know, because sometimes you're like, oh, okay, I took one out, so that's like less resistance, but also is in parallel. Like, let's just actually do the math. Let's say I had 1, 1, 1, and 1. These two are, and this is like for this one, by the way. So these two, the 1 and 1 are in parallel, so you do 1 over 1 plus 1 over 1, 1 over that. So that would give you 1/2 or 0.5. And then it would be 1 plus the 0.5 plus the 1, so see how your R total would be 2.5. Now for this one, if it's 1, 1, and 1, your R total is now 3. So actually my R total just increased. So if I have the same total voltage with this greater total resistance, then that means I have less total current. So now I can go to what happened to A. A has the exact same resistance because it's the same bulb, but now it has less current going through it because there's less total current in the circuit, and A got the total current, so then its voltage must have decreased. So the potential difference of A decreased because it now has less current, because the equivalent resistance, that's like R total, of the circuit increased. So I total decreased. What happened to the potential difference across C? 2 ways to do it. You could think about like your voltages, right? So because this one, like we still need them to add up, right? So if this one now is a bigger, or sorry, smaller voltage than before, then this one must be a greater because they still add up to the same total. That's one way to do it. The other way to do it is still talk about current. So yes, my total current has decreased, but before B and C were splitting that current, whereas now C gets all of it. So yeah, I have less overall, but now I don't split in half anymore, so C gets more of it. So C gets more current than before because it doesn't have to split I with B anymore. More current with the same resistance means more voltage across C. Number 15, we know that we've got R, 2R in series with battery V. At time R, at time T, this one has used a bunch, or an amount of energy E. How much energy has this guy used? So I here went immediately to power because I'm talking about time and energy. Remember, the definition of power is the rate at which it's using energy. So if I'm still talking about the same time, the one that has used more energy or less energy is the one that has more power or less power. So I know I'm talking about power here. Well, power is just IV. These two are in series, so I know they have the same I, so I'm just going to call it I, right? Now voltage, rearrange, is just I times R. So see how this one would have some voltage, and this one would have twice that voltage. So if I call this one V1, this one, because I'm multiplying with twice the R, would have twice that voltage. So then if you multiply the same current times this voltage and the same current times twice that voltage, see how if this one had a power P, this one would have twice P. So if this one is used an amount of energy E in the time period, this one will use twice E in that time period. Right here, we know nothing except for these two resistances, and we want to know this missing resistance. So how I thought about it is V equals IR, so R would just be I over V. Did I do that right? Yeah, V over I. I can do this. I is V over R, multiply R, divide I.